Today we're doing section 3.2, theorems about perpendicular lines. Our objective is to use theorems about perpendicular lines. We've got some warm-ups to get through. First, we are deciding if these angles are complementary, supplementary, or neither. We are also going to tell if they are adjacent or non-adjacent. All right, number one, who wants to raise their hand and tell me something they know about those two angles? Jaden. They are complementary because they add up to 90. All right, so we know that number one, those are complementary angles. Who can raise their hand and tell me if they are adjacent or non-adjacent? John? They are adjacent. They share a common vertex and a common side. All right, somebody else. Number two. Complementary, supplementary, or neither? Cade? Neither. They do not add up to 90 or 180. So there's nothing special about what they add up to. Somebody else raise their hand to tell me if they are adjacent or non-adjacent. Honesty? They are non-adjacent. They do not share a side or a vertex. All right, number two, we need to solve this equation, meaning we need to get x by itself. Jaden, what could we do? Good. Then what? I would agree.
2 divided by 38.
So,
19.
perfect. So we should end up with x equals 19.
6. You should get x equals 30.
Wonderful. Divide both sides by 6. So x equals 30. Good. Good. Then we would divide both of them. And x equals 6. Somebody new have ideas about how to do this one? Combine like terms. So we can combine the 2x plus x to give us 3x. And then what? Good. 3x equals 102. Finally, what's the last step? Divide by 3. What do we get for x? 34. All right, going on to today's notes. We have 4 theorems. They are listed at the bottom of your notes. You need to fill in the blanks. The first one is that all right angles are congruent. That should not be a surprise. Right angles measure 90 degrees. If more than one angle measures 90 degrees, those angles would be considered congruent. Second one, if two lines are perpendicular, then they intersect to form 4 right angles. Again, that should not be a surprise. If two lines intersect and they are perpendicular, then we should be able to show that all 4 of those would have to be right angles. The third one, if two lines intersect to form adjacent congruent angles, then the lines are perpendicular. So what that means, or what that looks like, is that if these two lines intersect and these two angles are congruent to each other, then that means those two lines were perpendicular. Because if we've got a straight line and they're split equally, they would both have to be 90. That's basically what that third one's saying. Lastly, if two sides of adjacent acute angles are perpendicular, then the angles are complementary. So again, if you have perpendicular lines, it's a 90-degree angle. If it's split into two adjacent acute angles, those two angles still add up to be 90. Why? We know that 2 is a right angle. What do we know about 1? It's also a right angle. If A and C are perpendicular to each other, then all 4 of these would be right angles. So we know that 1 is also a right angle. So we would say yes. And then we would have to list a couple different things. First of all, perpendicular lines form 4 right angles. And we know that all right angles are congruent. What do we think about angles 2 and 3? Are those congruent? So number 2, yes. Both right angles. All right angles are congruent. They're both right angles. All right angles are congruent. We can use the little symbol for congruence to shorten it up. Do we think angles 3 and 4 are congruent? So let's mark the angles that we know are right angles. If A and C are perpendicular, we know these are all right angles up here. We also know that B and D are perpendicular, so these are all right angles down here. Does that tell us anything about the intersection where angle 4 is? Do I know anything about the intersection of lines C and B? Did they tell us anything about C and B together up here? No, I don't know anything about that intersection. So I don't know. There's not enough information to decide. We can put not enough information. Those could be right angles there, but for right now, we don't have enough information to decide that. So if you want to write in, if you want to write in all your right angle boxes right away, you can do that. There we go. It's not necessary, but it could help. So what do we think about angles 1 and 2? Why? They're both right angles. Both right angles. All right, let's move on. Angles 2 and 3. Yes, why? Again, they're both right angles. If they're right angles, this makes it really easy. And finally, we've got angles 4 and 5. No, or at least not enough information. We were not told anything about line M, so we cannot assume anything about it. So we are told that angle RPS is congruent to angle RPT, and they marked that in the diagram with those little arcs. We are asked, our two lines intersect, they form congruent adjacent angles. That means the lines have to be perpendicular based on that theorem. Yes. So yes, they are perpendicular because those two lines intersect to form adjacent congruent angles. So RP and ST intersect to form adjacent congruent angles, which that fits that third theorem from the front. If they intersect to form adjacent congruent angles, then they are perpendicular. All right, number 4 is a similar situation, but it takes it a step further. In the diagram, we again have congruent angles, but we are asked if angle GPJ, so this angle down here, we are asked if that is a right angle.
Yes.
Why? We can't use that as a mathematical reason. So the first half of it, this picture looks a lot like the one from above, right? If we were to turn it just a little bit, we've got adjacent congruent angles formed by two intersecting lines. So that means what about lines GI and HJ? They intersect, but what kind of lines are they? What kind of lines do we have up here? Perpendicular. So we know that lines GI and HJ are perpendicular. So we can say GI is perpendicular to HJ. That's not it. What do we then know about perpendicular lines? They're not congruent. What kind of angles do they form? They form right angles. Perpendicular lines form right angles. So therefore, angle GPJ is a right angle. So we could have started out with a yes and then given our explanation after. Ooh, sorry. Anybody need more time on this slide?
Can you go back to the theorems?
At the end of the notes I can. We need to get all the way through the notes and then I'll go back. All right, on this one we are going to, on example 5, we are given another diagram. This time we are asked to find the value of x. So honestly, we've already done problems extraordinarily similar to this. We're just being given a different context. All right, like I said, we've done something similar to this before. This is just a new context. We are told that we've got perpendicular lines. They even mark it in the diagram then that we would have a right angle. So what do I know about these two angles, 20 degrees and 6x plus 4 degrees? They add up to equal 90. So we're going to add them together and set it equal to 90. And then we have an equation that we can solve for x. We did this when we were doing complementary angles the last couple weeks. First step, combine like terms. What gets combined? The 20 and the 4. We have 6x plus 24 is equal to 90. Then what can happen? Subtract 24, we get 6x equals 66. Last step. And we get x equals. Perfect. That's all they wanted was x, so we don't have to go back and plug it in. All right, again, these are not anything terribly new, just a different context. What do we know about the two little angles on number 6? They're complementary, which means they add up to 90. So that's what we're going to do. 8x plus 18 equals 90. We solve this just like we would in Algebra 1. What do? Subtract 18. 8x equals 72. And then divide. So x equals 9. Number 7 is a similar situation. Once again, what's the relationship between those angles? They add up to 90. They are complementary. So 40 plus 9y minus 4 equals 90. This time we can start by combining like terms. When we combine 40 and a minus 4, what do we get? 36. Back to solving it like Algebra 1. What do? Subtract 36. 9y equals 54. And then divide, and y equals 6. The last one, number 8, that one's a little bit different from what we've done. Anybody have any thoughts about number 8? Jaden? No? What did we know about these angles on, what was it, examples 3 and 4? What did we know about them? Well, we know these two angles are supplementary. Julian? That angle would equal 90. Okay, we had the congruent adjacent angles from the intersecting lines. We talked about that on examples 3 and 4, that these would actually be right angles. So that means I can just take this single expression and set it equal to 90. 13x minus 1 equals 90. This is not the only way to do this problem. If you were to duplicate it and put a 13x minus 1 on the other angle because they're congruent, and then add them up and set it equal to 180, that's another way of doing it. It's just going to take a little bit more work. So this way is the way I would recommend. What do we do to solve? Add 1. 13x equals 91. And then divide. X equals no, it comes out nicely. Connor?
I got x equals 7.
Perfect.